Hello there, this is Miss Nakayama, and today's lesson is 1.8 inverse functions. This is the last section for our current chapter, so something to be excited about. So in this lesson, we're going to talk about verifying inverse functions. We're going to find the inverse of a function, use the horizontal line test to determine if a function has an inverse, use the graph of a one-to-one function to graph its inverse, and then find the inverse of a function and graph both on the same set of axes. Okay, so first off, the definition of an inverse function is if you have two functions, f and g, and you compose them, which is what we did in the last section, and you get x, no matter which way you compose them, then f and g are said to be inverses of each other. Okay, this is a notation. F to the negative 1, read f inverse. Okay, and it's written mathematically like this here. F, right here, f of f inverse of x equals x. If you stop and think about this, y'all, if I take a number, think of a number, and then you add 5 to the number, and then you subtract 5 from the number, adding and subtracting are inverses of each other, you're going to get what you started with. That's what this is saying. And it doesn't matter if I do f of f inverse or f inverse of f. I'm always going to get x. Okay? And remember, they're inverses of each other, so the domain of f is equal to the range of its inverse. And we will use that to find domain and ranges of anything. But another example, okay, just to, come on. Okay, if I say f, what is f inverse, f of f inverse of 51? Then you should be able to tell me that's 51. What is f inverse of f of negative 6x? Then the answer is negative 6x. Whenever you compose two functions that are inverses of each other, you always get what you started with. Okay, so that is what we're going to do to verify inverse functions. Okay, here's a function and here's another one, and you're going to have to show the work for this on your test, on your mastery check to show me that you understand it. So you don't have to do both ways. You only have to do one of them. Okay, I'm going to do both of them. This is verifying, and I'm going to do both ways, whichever one is more comfortable for you. But in essence, y'all, this is like a geometric proof. Okay, you cannot skip steps. You have got to show me the work. Okay, so first off, the first one I'm going to do is f of g of x. Well, we always start on the inside, and g of x is this guy right here. So I'm going to do f of that guy right there. And then f says to take 4 times whatever you have in parentheses minus 7. 4 times whatever's in parentheses times minus 7. And I'm going to carry down what goes in parentheses. Now, you want to know that, however you wish to do this, that 4 and that 4, this 4 is on top, this 4 is on bottom, they cancel. So I'm left with, and I want to see this step, you're left with x plus 7 minus 7, which equals x. So I have verified, I have gone through and shown how when I plugged it in and simplified it, I got x. All right, let's look at it the other way. G of f of x, okay, what is f of x? Well, that's f of x. So that means this is going to be g of 4x minus 7. And then I'm going to go plug in. What does g say? G says whatever you have in parentheses, add 7 to it, and then divide it by 4. So I'm going to carry down and put it in my parentheses. And then when I simplify here, this minus 7 and that plus 7 are going to go away, and I want to see the next step, which is going to be 4x over 4, which simplifies to x. Okay, that's verifying. You're also going to have to just find the inverse of a function. And to do that, when it says y equals, you're going to replace f of x with y in the equation, and then you're going to interchange x and y, and then solve it for y. Okay? So watch. How are you going to do this? Here are these steps. Find the inverse of 2x plus 7. So it says find the inverse of f of x. So instead of f of x, I'm going to write y equals 2x plus 7. Then I'm going to switch my x and y. That says x equals 2y plus 7. And now I'm going to solve for y. So how do I solve that for y? It means I need to get y all by itself. So first off, I'm going to subtract 7 from both sides. And then I'm going to divide by 2. And you can leave it like that. You don't have to get anything fancy. At the end, replace y with f inverse of x. So that's going to be your answer. That's it. Okay? Now, just like we had a vertical line test for functions, we have a horizontal line test for inverse functions. Okay? And as long as there's no horizontal line that intersects the graph in more than one point, then we can say that it will have an inverse. For example, look at these two here. Which of the following graphs represent functions that have inverses? So I draw a horizontal line. Do I cross it more than once? I do. So this one is not, you can find the inverse of it, but the inverse of it will not be a function. So this one is no. Okay? Y'all, the vertical line test, if I draw it this way, the vertical line test, it does pass. It is a function, but this is telling me when I find the inverse of it, the inverse won't be a function. Over here, this is a function. It passes the vertical line test. The horizontal line test, I'm only going to cross it once, no matter what kind of horizontal line I draw. So this one actually, its inverse will be a function also. And it's really what we call one-to-one functions. Okay, so look at this. The graph of f of x, when you have inverses of each other, y'all, there will always be, when you graph them, you can tell whether or not you're graphing it correctly because the reflection, it will always be a reflection in the line y equals x. So if you have the point, where'd it go? Well, let's go with this. Okay, let's say I have the point fy on some function. I'm going to have xy, and then I'm going to have 3, negative 2. I'm just picking some points, y'all. And I'm going to have 0, 7. Then I know my inverse because what did we just talk about? Think about how did you find the inverse? We swapped the x and the y. So that means I know 3 points or 2 points. Any function on the inverse is going to be flipping these points. It's going to be yx. It's going to be negative 2, 3. It's going to be 7, 0. All right, so when you graph them, all right, you look at this point, and this point here is, well, I'll start down here. This is negative 3, negative 2. Negative 3, negative 2. This is negative 2, 2. This is 4, 1. So if I have negative 3, negative 2, then I know I'm going to have negative 2, negative 3. Where's negative 2, negative 3? Somewhere about right there. Okay, that's negative 2, negative 3. Nah, I'm going to leave it like that. If I have negative 2, 2, then I'm going to have 2, negative 2. 2, negative 2. If I have 4, 1, then I'm going to have 0.1, 4. And when you connect them, similarly, it will look something like that. Okay? Now, the key, as I said, how do you know if you've got it correct? Is if you graph them on the same set of axes, then you will see that they are a reflection around the line y equals x. And that's all you got. So I hope you'll write down whatever you need. What is the most important thing to remember about this lesson so that you can do well on your mastery check? Thank you so much for